So when we are talking about electric propulsion, we are talking about something which is already in space. So it's a satellite mainly, or a probe, but it's not a launcher. Okay. So the idea is that the reason for this is that electric propulsion is another way of giving thrust, so giving to push satellites, for example, but continuously. While, for example, on chemical thruster, which is the more conventional way of propelling satellites or even launchers, what you do basically, you give a lot of thrust all of a sudden, and then most of the time you leave your satellite to coast up to the final destination. So you have a lot of energy which is given right away to the satellite, and then you leave it along the orbit. Electric propulsion is the other way around. They do not provide a lot of thrust, but what they do is that they provide thrust all the time through till the final destination. So it means that over time you are gently pushing your satellites all the time through, and at the time you reach your destination, you are probably much faster than with the chemical one, because you are keeping pushing. You know, in space you don't have you don't have frictions, you don't have forces other than the gravitational forces. Right. So basically you can accumulate this acceleration up to speeds that are dramatically high. And the way in which you do this is basically you take a certain propellant, which is usually stored in conventional electric propulsion system, is a gas, is a noble gas like xenon, krypton, argon, these kind of things. And instead of, let's say, breaking down the molecules as we do with the chemical propulsion system and getting the speed out of the energy of the molecules, here what we are doing is that we give energy to the propellant, and we make it ionized. So basically we get an ion and an electron out of a neutral. And the idea is that through a combination of electric field or electromagnetic field, so a combination of electric and magnetic field, you accelerate ions. So these ions can be ejected at speeds that can be some tens of kilometers per second out of the thruster. So, and gave you a gentle thrust, because we are talking about, let's say, anywhere between micronewtons for very, very small thrusters up to 1 Newton max for a very big thruster. But you can do it with a very low consumption, let's say, which is a parameter which is called specific impulse. You can do it with a quantity of propellant which is dramatically less than a chemical thruster. So what's the advantage of this then? You know, first of all is mass, because if you don't have to bring a huge amount of propellant with you to do a certain amount of orbit, you can of course gain mass in your satellite. And mass is very, very critical, for example, for scientific missions. If you need to go to Saturn or to Mercury very fast, very far away, you cannot afford to bring super huge satellites, because with 90% of the satellite which you use for propellant, I mean, it makes no sense. On the other side, for small satellites and even more for big constellations, when you need to stack a lot of satellites in a launcher to reduce the number of launches to deploy your constellation, it's very, very useful to have electric propulsion, because of course, otherwise you will need to dedicate a lot of mass, and so a lot of launch capacity to the propellant and not to the payload. So what you really want, so the telecommunication payload, for example, the channels for your internet connections or for broadcasting. So electric propulsion basically can enable these kind of missions. So missions that are very far, like Dawn missions or Bepi Colombo, that has been recently launched by the European Space Agency, that they are going very far away in space, or like constellation like OneWeb or SpaceX or future constellations, they are all based on electric propulsion for this reason.
More engineers are not going to solve your problem. It's not a technical problem in that sense. It's a process problem. And the time to fix your processes was 20 months ago, and the second best time is today. This is Jason Canigan, the president of Cold Star Technologies and the host of this podcast, the Cold Star Project, which is all about identifying and solving process problems for space companies, because that's what we do. And you can hear the entirety of this episode by following the link in the comment below.